Good morning everyone. I am Tanushri Dalai from Civil Engineering branch. So in the last class we started the derivation part of the cantilever beam subjected to 1 point load at the free end, and today we will continue from this part. So after this, that means when we got our actual slope equation by finding out the C1 value, that is PL square by 2, and putting this C1 value in equation 1, we got our slope equation for the cantilever beam. Hence the slope equation is equal to EI dy by dx is equal to minus Px square divided by 2 plus PL square by 2. And now we have to find out the constant 2, that is C2 value. So for that we have to provide the condition 1, that is at free end when x equal to 0, y equal to 0 and C1 equal to 0, that we got from this part. And then when we put this whole value in equation 2, that is in the deflection equation, we got the value of C2 is equal to 0. Then for the next condition, that is at fixed end when x equal to L and y equal to 0, hence the C2 value will be PLQ by 3. Okay. So now we got our C2 value as PLQ by 3. Now we can put this C2 value in equation 3, that is in deflection equation, equation 2. So we know about C1 value, so we can put here PL square by 2x, and C2 value we got as PLQ by 3. Hence our actual deflection equation is equal to EIY is equal to Pxq by 6 plus PL square by 2x plus PLQ by 3. Hence we got our slope and deflection equation for the cantilever beam, which is subjected to a point load at the free end. So now for the maximum slope and maximum deflection value, we need to put some condition by which we can find out the y max and dy by dx max value. So first of all, for the finding out the maximum deflection value, we have to put x equal to 0. That means we know that the deflection of the cantilever beam is about its loading condition, that is at the free end. So that's why we have to put here x equal to 0. So now we have to put this value in actual deflection equation, that means here. So now x equal to 0, so this term will be 0 and here also x will be there, so that's why this whole term also 0. Hence EIY is equal to PLQ by 3. Now if we provide y max value is equal to PLQ by 3 EI, so y max is equal to PLQ divided by 3 EI will be the maximum deflection for the cantilever beam. And now comes to the maximum slope. So we know that at the free end maximum slope will be there. So that's why again we have to put x equal to 0 in the actual slope equation, that means here. So now by putting the x equal to 0, this term will be 0 because here x is there. Hence EI dy by dx is equal to PL square by 2. So now dy by dx max will be PL square by 2 EI. So for the cantilever beam, point load at its free end, the maximum deflection will be PLQ by 3EI and maximum slope will be PL square by 2EI. So now we have to solve a numerical. So here a cantilever beam is there which span is 3 meter and here the point load is provided as 6 kilonewton and in the data given E value is there, that is 210 GPa. So which equal to 210 10 to the power 3 Newton per mm square. Hence, we have P value, we have L value, we have E value and also we have moment of inertia value, that is 10 into 2 10 to the power 2 centimeter to the power 4. By converting this centimeter fourth into mm fourth, we have 16 into 10 to the power 8 mm fourth. So now we have to find out the maximum slope and maximum deflection of this beam. So we know that for the maximum slope, the value of the cantilever beam which is subjected to point load at its free end, the value is PL square by 2EI. So by putting P value, L value, E value and I value, we have the value of slope, that is theta, is equal to 8.0357 into 10 to the power minus 5 radian. So always remember the slope value will be always in radian. So now the deflection is equal to maximum deflection for this kind of beam is equal to PLQ by 3EI. So now we have P value as 6 into 10 to the power 3 Newton, L value is 3000 mm, E value is 210 into 10 to the power 3 Newton per mm square, I value will be 16 into 10 to the power 8 mm fourth. So by putting all this value, we have 0.161 mm. So for this kind of beam having the point load at free end, the maximum slope value will be this much and maximum deflection value will be this much. So this is all about your slope and deflection derivation for the cantilever beam with point load at its free end. So this is all about your double integration method for the cantilever beam. So we will discuss another beam with other type of loading condition, that is UDL type of loading condition. So we will discuss about this beam in the next class. So today this much. Thank you.